In the final video for Lesson 3 of Section 4 and the final video for Unit 7, we will examine one more example of two independent events where the results of an experiment have been provided, and we have to determine the experimental probabilities, then compare them to the theoretical probabilities for the same set of events. Let's consider this example. A spinner has 3 equal sectors labeled J, K, L. A jar contains 4 congruent cubes having colors blue, green, red, and pink. The spinner was spun and a cube was drawn from the jar 36 times. The results of the experiment are provided in the table. So we are not going to actually spin the spinner and pick the cube. That's already been done for us. The experimental results are shown. What we have to figure out, first of all, the probability of spinning a K and choosing a red cube. In my table, I look at the K, I look for the red, and where that row and column overlap, that's the number I'm interested in. There's a tally there of 4. Those are the favorable outcomes for K and red out of 36, which I can reduce to 1/9. B, what is the experimental probability of spinning L and choosing blue or green? I know it's going to be out of 36. I look for my row of L, and then it can be either blue or green. I add both of those tallies and I get 5. So my experimental probability, 5 out of 36, which cannot reduce. And I'm only putting my probabilities here as fractions. Not going to bother to put them in all the forms. And in C, the experimental probability of choosing pink. What I spin on the spinner this time does not matter. I'm only looking for my pink. And I add all of the values in that column, which gives me 8 out of 36. Pink was spun 8 out of the 36 times. This will reduce because 4 will go into 8 and 36 nicely, giving me 2/9. Those are my experimental probabilities. Let's compare those experimental probabilities to the theoretical probabilities for this example. Our sample space, JKL for the 3 sectors on our spinner, and then we have the 4 different colors of cubes that we can associate with each letter on the spinner. We can have spin a J, pick a blue, spin a J, pick a green, spin a J, pick a red, spin a J, pick a pink. And we follow this idea to complete the other 2 sections. Spin L, pick red, spin L, pick pink. First probability that we considered in the example for experimental was the probability of spinning a K and picking a red cube. I'm looking for KR right here. So my favorable is 1. There are 12 possibilities. This would in turn give us 3 out of 36. And we note that that's pretty close actually to the 4 out of 36 that was obtained in the experiment for this same example. We then looked at spinning L and blue or green. Theoretically, I would have 2 possibilities here out of 12, which would reduce to 1/6. Out of 36, that would be 6 out of 36, and that too is close to the experimental results that were obtained in the previous table. That probability being 5 out of 36. And finally, the probability of pink, we have 1, 2, 3 possibilities for just pink, giving us 3 out of 12, which would reduce to 1/4. For comparison purposes, if I write that probability out of 36, I would get 9 out of 36. And if we compare that to the experimental results obtained in our table, there were actually 8 times when a pink cube was chosen out of 36. Again, pretty close. In no case did our experimental results totally agree with our theoretical, but remember, that's fine. Remember too, however, if this experiment was carried out enough times, If there were enough trials, the experimental probabilities would indeed approach the theoretical. That's a proven fact. Please proceed now to the final set of activities for this unit.